Struggling with partial fractions in paper 3. In this video, I'm going to show you 3 types of partial fractions you must know and exactly how they appear in exams. And if you master these, you'll pick up easy marks every time. One is linear factors. Let's take an example. 3x plus 5 divided by x minus 1 and x plus 2. Okay, this is type 1 because when you look in the denominator, you see two different linear factors. This is one factor and this is the other, both are linear, and therefore it is type 1. Now type 1 fraction can be broken up into two partial fractions. The first one we write a over x minus 1 plus b over x plus 2. Right? So the aim now is to find a and b so that we can then say our fraction is equal to two partial fractions, a over x minus 1 plus b over x plus 2. Okay, how do we solve for a and b? You take x minus 1 and x plus 2 as the denominator on both sides. So you get 3x plus 5 is equal to a multiplies into x plus 2 plus b multiplies into x minus 1. Right? So now we have an equation. We're going to solve for a and b. So how do we do that? There are a couple of ways to do it. One simple way with linear factors is equate each of the factors to 0. So I'm taking x plus 2 equal to 0, which gives me x is equal to negative 2. And I substitute that into this equation here. So what does that do? 3 into negative 2 plus 5 equals a times, we already said x plus 2 is 0. So a into 0 plus b negative 2 negative 1. So negative 6 plus 5 is negative 1 is equal to negative 3b, which tells us that b is equal to 1 by 3. Similarly, we can solve for a. How do we do that? We take this factor here and equate it to 0. So x minus 1 is equal to 0, which means that x is equal to 1. Now we substitute that into this equation here once again. So 3 into 1 plus 5, which is equal to a times 1 plus 1. And we've already equated x minus 1 to 0, and therefore it is b into 0. So we get 8 is equal to 2a and a is equal to 4. So once we've identified the values of a and b, we can then rewrite our equation, putting it in a different color here. So our partial fractions are now 4 over x minus 1 plus 1/3 of 1 over x plus 2. And that's how the first type of partial fractions is done. Whenever you see a different set of linear factors in the denominator, you have to split it up. It is type 1 and you have to split it up into a over the first linear factor plus b over the second linear factor plus c over the third linear factor, and so on. Type of partial fraction involves repeated linear factors. So I'll give you an example. Suppose you have 2x plus 1 divided by x minus 3 the whole square. So if you look at the denominator, it is a repeated factor, x minus 3. This simplifies into partial fractions that look like this. A over x minus 3, this is without a square, plus b over x minus 3 squared. Students usually forget one of these. Either they forget to have an a over x minus 3, or they forget the b over x minus 3 squared. Remember, you need to have both of these fractions. Now, what we do to simplify this is whatever LCM you have on the left side. So over here we have x minus 3 squared. Use the same LCM for the right side. And so our equation simplifies to 2x plus 1 is equal to a times x minus 3 plus b. Now we proceed in the same way as we did type 1, which is try and eliminate each of the constants. So I'm going to do x minus 3 equal to 0 so that I can eliminate a and find b. In this case, x is 3, which we substitute. So 2 into 3 plus 1 is equal to a into x minus 3 is 0 plus b. So 6 plus 1 is 7 is equal to b. Right. Now, in order to get a, what we can now do is, so since there are no more factors to equate to 0, what we can do is expand it fully. So 2x plus 1 is equal to ax minus 3a plus b, which is 7. Okay. And now what we do is we just equate like terms. So the x term on the left is 2x and on the right is ax. So we can just equate that. So 2x is equal to ax. So a must be 2. So that's it. Now we just replace it in our original equation here. So the partial fraction form of 2x plus 1 over x minus 3 the whole square is 2 by x minus 3 plus 7 over x minus 3 squared. So remember, if you have repeated linear factors, it splits up into two partial fractions. The first one with just the linear factor in the denominator, and the second one with the linear factor squared in the denominator. The third type of partial fraction is called the irreducible quadratic factor. So I'm giving you an example. 4x plus 7 over x minus 1 x squared plus 1. So here there are two factors in the denominator. This one is linear, which we've already covered as type 1. And this one is the irreducible quadratic factor. We're calling it irreducible because we can't break it up further into two factors the way you can with some quadratic terms. So this particular one can't be split up into two smaller factors, and therefore it is irreducible. For this, it goes like this. The linear expression gets a constant on top, so a over x minus 1. And the quadratic term gets a linear expression on top. So if there's a quadratic in the denominator, such as x squared plus 1, in the numerator, it won't be just a constant. It will be an entire linear expression. So in this case, I'm going to write it as bx plus c. So there should be an x term as well as a constant. Right. Now we just simplify it by taking the LCM on the right-hand side. So 4x plus 7 equals a times x squared plus 1 plus bx plus c into x minus 1. And then we go about finding out the values of a, b, and c. So to do that, first you take your linear factors, equate them to 0 one by one. So x minus 1 is equal to 0. X must be equal to 1. We substitute that. So 4 into 1 plus 7 equals a times 1 plus 1 plus b plus c into 0. So that is 11 is equal to 2a, which means that a is 2 by 11. Right, that leaves us with b and c. At this point, there are no further linear expressions that I can equate to 0, and therefore I just expand the whole expression. So 4x plus a whole equation. 4x plus 7 is equal to a x squared plus a plus b x squared minus bx. I'm expanding this equation here, plus cx minus c. We already know that a is 2 by 11. So 4x plus 7 is equal to, it's ax squared. So 2 by 11 x squared plus a, sorry, not a. It's going to be 2 by 11 plus bx squared minus bx plus cx minus c. Okay, now we're going to equate like terms. So there is no x squared term on the left, so that's 0 is equal to 2 by 11 x squared, that's this, and the other x squared term is bx squared. Right, so we get bx squared is equal to negative 2 by 11 x squared. The x squareds cancel out, and b is negative 2 by 11. And then finally, we want to find c, so we'll equate some more like terms. So let's say we equate the x terms. So there's a 4x here, there's a negative bx here, and there is a cx here. So I'm going to do 4x is equal to bx squared plus cx. Oh, sorry, not bx squared. Bx, negative bx plus cx. All the x's cancel out. So 4 is equal to negative. B is already negative 2 by 11 plus c. So c is equal to 4 minus 2 by 11. 44 minus 2 is 42. So 42 by 11 is c. So now that we have a, b, and c, we can substitute it back into our original equation. So a was 2 by 11. I'm putting it in here. 2 by 11 x minus 1 plus b is negative 2 by 11 and c is 42 by 11. So negative 2 by 11 x plus 42 by 11, the whole by x squared plus 1. You can simplify it if you like. So remember, if there is an irreducible quadratic expression such as x squared plus 1 in the denominator, on the top you have a linear expression bx plus c. finally, let's look at some common mistakes in partial fractions. The first one is forgetting repeated terms. That means if you have x minus 2 the whole squared in the denominator, remember that it has two partial fractions, one with x minus 2 and the other one is with x minus 2 the whole squared in the denominator. If the factor is an irreducible quadratic factor, then your numerator is going to be a linear expression ax plus b. Don't forget to factorize fully and expand correctly. And finally, remember to check the degree of the numerator and denominator. Now, what do I mean by that? I'm going to explain this in another video coming up next. If you found this helpful, make sure you check out my paper 3 series. I break down the exact topics you need to score. And don't miss my video on common partial fraction mistakes. That's where most students lose marks.